2.3a permutations. So permutation is of n distinct items is an arrangement of all of the items in a definite order. Okay, when we order all of these items, we can use this permutation notation. So NPN, or like these are exactly the same, Pn comma n. Okay, and what this means is this is equivalent to n factorial. So this is n times n minus 1 times n minus 2 and so on. So this is a formula since there are n ways of choosing the first item, and then once that item is slotted in, there's n minus 1 ways of choosing the second item, and as soon as that item is slotted in, there's n minus 2 ways of choosing the third item, and so on. So we can use the fundamental counting principle and multiply these items, which turns out to be a factorial. Okay, so in the calculator, we use shift. Usually it's the second mode, and you got to find the NPR button. Okay, so the steps is what you want to do first, usually, is you want to put in the n value, press shift and then NPR, and that'll pop up a P in the calculator, and then input your R value. And then we just press equals. So here's the difference between NPN and NPR. So if we have n items, but we're only ordering R items out of that n, then we put in the R. And it changes a little bit because this time it's not just a straight factorial. There's actually, it's n factorial over n minus R factorial. Okay, the number of items that you have must be greater than or equal to the number of items that you want to order, because obviously you can't order more items than you actually have. So let's play with this formula here. I'm gonna leave that on the board. So solving using permutation equation and then the underline method. Okay, and then check your answer using your calculator. So ordering all items. Here's our first question. A photographer arranges 6 people in a line. In how many different ways can they be positioned? So we're going to use the permutation equation first. That's going to be 6 factorial. And if we put that into our calculators, that's simply 720. But if we use the underline method, that turns into 6 times 5 times 4 times 3 times 2 times 1, which is actually also 720. Okay, I use 6 factorial here because it is 6p6. If you put 6p6 into your calculator, it's going to also give you 720. Okay, so there's actually 3 different ways to do this one. And then when we check, we're good. That's our 720. Now, this one's a little bit different because it's ordering some items. So the permutation equation on a team of 13 swimmers, so we have 13 altogether, how many different ways can the swimmers win gold, silver, bronze? So we're going to order 3 of those individuals. So if we do that, we get that 17, 16. Okay, underline method. Okay, gold, silver, bronze. There are 13 possible individuals that can come in first place to win gold. But once that person crosses the finish line, there's only 12 people left to win silver. Once that person crosses the finish line, there's 11 left. Okay, so if we do 13 times 12 times 11, we also get 17, 16. The other way we can do it is the n factorial over n minus r factorial, which is 13 factorial over, this is going to be 13 minus 3 factorial. So if you think about 13 times 12 times 11 times 10, that can be all over 10 factorial. These end up being the same thing. So our check is good. They all equal 17, 16. So multiple ways of doing this, and all of these ways are valid. Now, here are a couple special cases. Okay, n items, arrange all of them. that's going to simply be NPN or n factorial. Okay, you don't need these equations in the middle. It's just a simplified version. Okay, n items arrange r of them, so NPR. And then n items arrange none of them, it actually simplifies to 1. So if we're not able to arrange, if we're not arranging any of the n items, then technically that's a way to arrange them, is not arranging them. Okay, and some buzzwords, we're looking for questions with specific jobs or roles, right, where the roles are unique and it matters who's chosen for each job. So example 2, in how many ways can a president, vice president, and secretary be chosen from 10 nominees? This is simply 10P3. There are 10 nominees, and we're ordering 3 of them for president, vice president, secretary. Okay, so I get 720. Now, how many 3-letter words can you create if you're given 7 different letters? So 7P3. Oh, 3 again. That's okay. It's not always going to be 3. I get 210. So I'm going to highlight this. When we're talking about words or even numbers, license plates, these are all items that you would order. Because if you think about the word, let's go ACE. I think that's one of my examples. ACE is not going to be the same as AEC. Those are not the same. So order actually matters when we're spelling or numbers. If you have $120 in your account, it's very different than having $102 or 012. Okay, so order matters when we're dealing with numbers as well. Now, let's talk about permutations with some identical items. So, if we order the letters in the word doll, there's an issue because doll has 2 L's that are identical. So we can't actually tell them apart. Therefore, we must only take into account the orderings that do not repeat. So like above, ACE, let's list all permutations of the following words. So ACE, AEC. Then let's start with C, CEA, CAE. Then let's start with the E, ECA, EAC. So there are a total of 6 different ways or different permutations of the word ACE. But here's the issue. When we have I, we have the first E and the second E. But if we write this as I with the second E and then the first E, these 2 words we can't actually tell apart. So this is a duplicate. So it's not a unique permutation. Okay. Likewise, if we have YEE and YEE, but it's the first E, then the second E, and then the second E, then the first E, this second spelling is identical. So we don't count it as a new permutation. And then EEY and EEY, again, first, second, second, first. This is not unique. So the total for the letters in the word I, EYE, is actually only 3. So how do we do this without listing? Okay, permutations with some identical items. When dealing with permutations of n items that include A identical items of one type, it could be 3, could be 8, we don't know. Okay, B identical items of another type, C identical items of another type, and so on. What we end up doing is we take that factorial and we divide out the duplicates. So if there's, like, for example, 3 duplicates of something, and then 2 duplicates of something else, and then 4 duplicates of something else, that would be our denominator. 3 factorial, 2 factorial, 4 factorial. So let's redo this question here, but let's actually just do it with permutations. So ACE, that is going to be 3 factorial. There's 3 letters, and we're going to order all 3 of them. I would also be 3 factorial. Here's the issue. We have to divide out, there's 2 E's. So this is going to identify our E's. So 3 factorial times 2 factorial, we just get 3. Okay, so example 2. Frank is laying tiles on his floor. He has 4 red, 6 pink, and 3 green. How many patterns can he make? So in total, how many are there? There's 13. So usually you would say, oh, like we can just like put them in order, 13 factorial ways. But the problem is the 4 red tiles we have to divide out, the 6 pink tiles we divide out, and then the 3 green tiles we're also going to divide out. Okay, and then you can actually divide that or just leave it. Okay, that's going to be a big number. Now, Maria is arranging books on the shelf. She has 5 fiction books, 3 non-fiction books, and 2 mystery books. Okay, so in our original thought, we're like, okay, she has 10 books. So you think for a second that she can order them in 10 factorial ways. But if we're talking about actual genres, let's divide out the 5 factorial ways she can do fiction, 3 factorial ways of nonfiction, and 2 factorial ways of mystery books. Okay. Example 4. How many permutations are there of the letters in the word regression? So what I usually do is I usually rewrite the word R-E-G-R, and when I find a duplicate, I end up stacking it on top of each other. E-S-S-I-O-N. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 letters. So originally you'd think, okay, we can order these in 10 factorial ways. But there's 2 R's, so divide out the R factorial. 2 E's, divide out the 2 factorial. And 2 S's, divide out the 2 factorial. Okay, let's do the same with Mississauga. M-I-S-S-I-S-S-A-U-G-A. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so it's not 11 factorial because there are duplicates. We have 2 I's, so divide out 2 factorial. 4 S's, so that's a 4 factorial. And 2 A's, so that's a 2 factorial. Now let's try successes. S-U-C-C-E-S-S-E-S. 1, 2, 3, 4, 5, 6, 7, 8, 9. I believe that this is 9 factorial. Divide out 4, 2, and 2. So 4 factorial, 2 factorial, 2 factorial.